Alright, this last example is the most complicated. If you think you can solve it by yourself, I encourage you to pause the video, try to solve it by yourself, and then play through the video real quick and see how you did. Once again, we can start off by setting these equal to each other because they both equal y. So if we do that, we have x over x minus 3 minus 3 over x minus 4 equals negative 3 over this. I'm just going to go ahead and factor this now just because I know that that's what's coming. So I'm going to just go ahead and factor this. So let's see, x squared can only be x times x. 12. Alright, looking at that 12, that's either going to be 3 times 4 or 2 times 6 or 1 times 12. Alright, looking at the negative 7, I'm thinking 3 times 4. So 3 and 4. Inner plus outer equals middle. Inner I have 3x, outer I have 4x. The middle is negative 7. Okay, both of these would have to be negative to make negative 7, so boom, boom. A negative times negative is a positive for the positive 12. So this is working. And oh look, it matches what we have in these other denominators. So our strategy will be to get these denominators the same, and then once the denominators are the same, we can cross the denominators out. Let's see. So I have x minus 3 here. That matches this. But I also need an x minus 4. So I'm going to go ahead and put an x minus 4 with it. I can do that as long as I put x minus 4 in the numerator as well. So now that matches. This denominator has the x minus 4. It needs x minus 3. So I'm going to put x minus 3 in the numerator and the denominator. Like that. Okay, now I can cancel these out. Let's pay attention to our excluded values real quick. So from the x minus 4, I know that x cannot equal 4. And from the x minus 3, I know that x cannot equal 3. So let's make sure that none of our solutions turn out to be these. Be very careful how you deal with this subtraction. I am going to make sure that I put this minus sign on this negative 3 so everything happens the way it's supposed to. So I'm going to do that now by turning this into a plus and putting that minus right on that 3. Okay, just got to be real careful about that. So now I can cross out these denominators and see what I have. That thing about the negative 3, that's crucial. A common mistake is not to distribute the negative. So in a minute, when I do the distributive property with this 3, I'm not going to distribute 3, I'm distributing negative 3. That's crucial. I should get a positive 9, not a negative 9. Anyway, so I am going to distribute. So I have x squared minus 4x from this, and then plus, sort of, negative 3x, and then plus 9, like I said, is equal to just negative 3. Okay, so combining like terms. So here I have x squared minus 7x, all right, putting these two together, plus 9 is equal to negative 3. Let's add 3 to both sides. So that'll be x squared minus 7x plus 12 is equal to 0. Now perhaps this is factorable. By the way, if this ever does not factor, then I have to use the quadratic formula. So just keep that in mind. It doesn't have to factor. It won't always factor. So x times x, 12. All right, 12 is either going to be 3 times 4 or 2 times 6 or 1 times 12. Looking at the 7, didn't we just do this? No, it's exactly the same as what we had here a minute ago. And we already saw this turned out to be x minus 3, x minus 4. That's weird. So, setting each of these equal to 0, x minus 3 is equal to 0, x minus 4 is equal to 0, that's going to give me x equals 3 and x equals 4. Now, normally I would go into a whole spiel about how, be careful, these are x values, and we need to find the y values that go with them. So we'd have our 3 and our 4, and we'd have to use one of these two equations to find the y values. But I'm not going to do that because I'm noticing that these solutions, the 3 and the 4, these are the excluded values. So these values are not valid. So these were my only solutions. Both of them are excluded. So that means the answer is no solution. No solution. Okay, so there's that. All right. Now I could check this graphically, but all it's going to show is that there is no intersection point between these two equations. And I guess here's what the system looks like graphically. Just is sort of the one function is nestled inside of the other function. And they're both approaching the same asymptotes, but you know, so they never meet. For example, if I zoom in on this section right here, you see that I have one function inside the other, but they never do touch.